Okay, guys, good morning. Let's begin on page 7. It says an amortized loan made at annual effective interest rate 6.6% is to be repaid over 15 end-of-year payments of $1,800. What proportion of the loan's interest is paid in the first 5 years? So timeline, 15 years, $1,800 each year. What proportion of the loan's interest is paid in the first 5 years? So, how much is a loan? Yep. The loan is equal to the present value which is equal to what? Can I say 1,800 A angle 15 at 0.066? That's my interest rate, right? Okay, so what's the total interest paid? Because it says what proportion of the loan's interest is paid in the first 5 years. So I want interest in 5 years divided by total interest. So I have to go find both these quantities. So let's talk about the bottom first. Total interest paid in 15 years. So there's a formula for interest paid in n years. I'll write it on the top. Interest paid in n years is equal to the total payments in n years minus the decrease in outstanding loan balance. Decrease in what should we say? Decrease in principal loan balance. Principal loan balance. So this part is obtained by OLB0 minus OLBN. So as we know from the amortization schedule, if you take the OLB0 minus the OLBN, it will give you the sum of the principal payments within those years. That's the difference, right? Let me turn to an amortization schedule to show you. I'm saying, so let's say here's an amortization schedule. I'm saying that the difference between here and here, let's say, is equal to this plus this plus this plus this, right? That's what I'm trying to say here, that I'm taking all the payments minus the principal payments. So the sum of the principal payments is the difference between the outstanding loan balance in those time frames. You follow me? Okay. So continuing with our problem, total interest paid in 15 years. Can we use this formula to plug in here? Can you help me? I want total payments. How much are the total payments in 15 years? Minus decrease in loan balance. How much is the total payments? How many payments have you made in 15 years? How much in payments?
15 times 1800.
Yeah, 15 times 1800 minus what? Decrease in loan balance. So in 15 years, in the beginning of the 15 years, you had a OLB 0 of the whole loan. And at OLB N is 0. The outstanding loan balance at time N is 0 because you've paid the whole loan. So what I'm saying is that this is the whole entire loan. Because I'm talking about OLB 0 minus OLB at the end, 15, where this is 0 and this is the whole loan. That's what I'm trying to say. So for this one, I'm just going to say the whole loan, which is 1800 A angle 15.066. Are you with me? Let's clean that up. So 15 times 1800, 27,000 minus 1800, 1 minus v to the 15 over 0.066, and this gives me 10,183.39 because this mess was 16,816.61. Now I do the same thing but only for 5 years. Interest paid in initial 5 years. So total payments, 5 times 1800 minus decrease in principal loan balance, meaning the sum of all the principals paid. So this would be OLB 0 minus OLB 5. That'll give me the sum of the principal payments made in those years. So minus, let's see, this is 9,000 minus 1800 A angle 15 at 0.066 minus 1800 A angle what? 10. Because when you stand at time 5, you have 10 payments left. And then we clean that up. So 9,000 minus 1800, 1 minus v to the 15 over 0.066 minus 1800, 1 minus v to the 10 over 0.066. So I get 9,000 minus 3937.05, which gives me 5062.95. So to answer the question, the proportion is equal to 5062.95 divided by 10,183.39. So 0.497. 50%. So the moral of this story is that 50% of the interest was paid in the first third of the loan. Something to consider if you refinance, right? That in the first few years you're going to be paying the majority, the 50% of the interest, total interest. So let's write it. Half the total interest is paid in the first third of the loan's term. So of course this should go on your cheat sheet. Next page. Sinking fund. Let's say that you need $100,000 because you're going for a 4-year degree. Okay? You need $100,000 for room and board and tuition. So you borrow this $100,000 from your mom. You have choices as to how you want to pay this money back. You can pay this back as an amortization, meaning you can start making monthly payments or annual payments such that every payment includes interest plus principal. Or you can say, you know what, Mom, I'm just going to give you interest for the 4 years that I'm in school, and when I graduate, I will pay you back the principal amount. So on the $100,000 that you borrowed from Mom, you're just going to pay her interest just to keep her happy. Keep paying her interest. You will pay the principal amount at the end of the 4 years. You understand the difference between that and amortization? Amortization means you will pay part of the principal and part of the interest the whole time as you go along. So now to collect that $100,000 that you owe Mom, and you're going to pay her at the end of the 4 years, you have some options. You can collect it in your piggy bank, or you can collect it in another savings account. Let's say that you put it in the credit union at college, and that credit union is going to pay you 1.5%. That will help you pay off the loan, right? That means that you have to collect actually less than $100,000, which will accumulate to $100,000 at the end of the 4 years, and then you will pick that up and give that to Mom. You follow me? That credit union account is called a sinking fund. It's where you accumulate the loan balance such that at the end of the term of the loan, you pick up that $100,000 that's been accumulated there and you give it back to the lender, which is Mom. Follow? Okay, so let's read. This is a loan repayment strategy such that over the life of the loan, the borrower makes only interest payments each period to the lender. So I'm saying that the interest payment will be I times L, because here's I, the interest rate, times the amount of the loan. So let's say Mom is charging you 3%. You're going to be paying 3% of $100,000, right? Every year. $3,000 you'll pay Mom. Plus one final lump sum payment of L at the end of the life of the loan, underline end, to pay off the entire loan. To accumulate the lump sum payment L to be made at the end, the borrower uses a sinking fund. This is a fund accumulated over time with the intention of being sufficient to pay off the original loan balance, but the payment occurs at the end of the life of the loan. The interest rate on the sinking fund account is denoted J. So usually, J is less than I. This method is usually attractive for a few reasons. The borrower knows that the interest paid IL to the lender periodically is the price of doing business. Therefore, he doesn't mind paying this interest each period. He will then use the power of another interest-bearing account at interest rate J to help achieve his goal of accumulating L by the end of the loan. Usually when you pay off a loan, the payments decrease your OLB. Not the case with sinking fund method. In other words, you're not paying off any of the principal, right? So your OLB never goes down because you're just keeping Mom satisfied by giving her 3%, 3%, 3%, and never paying her back the original $100,000 until the very end. So your OLB will never go down until the end. the balance during the life of the loan does not decrease as the borrower is making only interest payments. One hopes that the interest rate the borrower is earning is high enough to somewhat offset the payments IL that he makes each period to the lender. So here's conventionally I is used for the interest on the loan to mom, and J is used as the sinking fund account interest. They're usually different, and like we said here, usually J is less than I. Q is the required sinking fund deposit. So think about this, right? This is what's happening. You take a loan of L. So I call it minus L because mom is dishing out L. And you are going to give mom at time 1 IL, at time 2 IL, at time N IL. So this is happening at interest rate I. And then here's the sinking fund account, where the accumulated value of this account has to be L. And this is occurring at interest rate J, and therefore each payment will be Q. And so I'm going to set up an equation that says accumulated value is equal to Q S angle NJ. And therefore Q is equal to accumulated value, which is the loan amount, divided by S angle NJ. Does this make sense to you? Repeat all of it? Yeah, so in my sinking fund, I am putting in some value Q such that these Qs have to accumulate to L, because I'm interested in collecting $100,000 at the end of 4 years, right? So I'm saying what should be my payments into this account, into the sinking fund, such that these Q payments, payments of Q, will accumulate to L at the end of the term of the loan at interest rate J, because the sinking fund is only earning J, not I. So I say L equals Q times S angle NJ. Therefore, Q is equal to L over S angle NJ. So the total payments due every period are IL plus L over S angle NJ. This one is to the lender. And this one goes into sinking fund. Make sense or no? Because as the borrower, you need to come up with two pieces. One piece to keep paying mom, IL, 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 IL for 4 years. And you also need to come up with the Q such that the Qs will accumulate to 100,000 at time 4. Get it? So this is the total payment that the borrower has to come up with. Get it? Okay. So question, a sinking fund schedule is a table which tracks payments and progress made on the repayment of a loan made by the sinking fund method. So the next question, example 5.3.2 from text. A loan for $2,000 was made with annual effective interest rate 5% using the sinking fund method with a sinking fund account available with annual interest rate 2.5%. Okay, so this is your I equals 0.05 and J equals 0.025. You have a payment of $800 at 1, payment of $1,000 at 3, and the loan is fully repaid at T equals 4. Create a sinking fund schedule for this loan. Let's do it. So first column, time. Next column, interest to lender. Which is equal to IL, right? So let's write that on top. I times L. Next one, sinking fund deposit. Next one, interest on sinking fund. Next one, sinking fund balance after deposit. And lastly, net OLB. Let's start with time zero. Time zero, nothing is happening. You owe $2,000 on this loan. So net OLB, $2,000. Next, time one. It says over here at time one, a payment of $800 is made at time one. So first thing I have to do is figure out, what do I owe mom? What do I owe the lender, right? So here, 200 times 0.05. That's my IL. 2,000, thank you. 0.05 times 2,000. How much is that? $100? Thanks. IL, 100. Now it tells me that a total payment of $800 is made at time one. So I only have $700 left to put into my sinking fund. So these two add up to the total payment, which is $800. Interest on the sinking fund is nothing, because there's nothing in the sinking fund at the previous time period, which is 0. There was nothing there that would grow at 2.5%. So there's no interest on the sinking fund. And the sinking fund balance after deposit is the $700 that I just put in. So the net OLB is equal to 2,000 minus 700, which is 1,300. Does this make sense? Keep going. Time 2, nothing is happening, right? The next payment is at time 3. So time 2, nothing. Leave that whole row blank. Time 3. They told me that a payment of $1,000 is made at time 3. But before I can do that, I have to pay mom, IL, right? So let's figure out this IL. This would be $2,000 times 1.05 squared minus 1. This is 2-year interest, right? So nothing happened the previous year. I never gave her anything. So I have to worry about 2 years interest. 2,000 times 1 plus I squared minus 1, that is 205. And they told me that a total payment of 1,000 was going to be made at time 3. So this total is 1,000. Which means $795 goes into the sinking fund. I only have $795 left after I pay her the IL. The next one is the interest on the sinking fund deposit. So take this $700 right here that was sitting in the sinking fund times 1.025 squared minus 1. Again, it's 2 years of interest. So $35.44. Sinking fund balance after the deposit is equal to 700 plus 795 plus 35.44, which is 1530.44. And therefore the net OLB is 2,000 minus 1530.44, which will be 469.56. Does this make sense or no? Any question so far? Then you go to time 4. The loan is fully repaid at time 4. First, I got to figure out how much to give mom back, I times L. So 2,000 times 0.05. I owe her $100 in interest payments. I don't know what I'm going to have to put into my sinking fund because they didn't tell me what the payment would be. What I do know is the interest on the sinking fund. So since I have 1530.44 in the sinking fund, I know that I will have 0.025 times 1530.44, and that will be my interest. That turns out to be 38.26. I also know that I have to have accumulated $2,000 in the sinking fund at time 4. So 2,000 at time 4 into the sinking fund. So I have to figure out what my sinking fund deposit is. How about 469.56? This is what my net OLB is, minus the interest from the sinking fund, 38.26. That means that I have to make a payment of 431.30. So the total of this plus this is 531.30. Total payment at t equals 4. What part of this can I clarify? David?
So at t equals 3, why did we go from multiplying by 0.05 to like 1.05 squared minus 1?
So if you're calculating 1 year's interest, you can take the amount and times it by 1.05 minus 1 in brackets, which is just 0.05. But if you're calculating 2 years interest, you have to take the amount times 1.05 squared minus 1 to calculate the 2 years interest. So when it's only 1 year, I don't bother to write it like here. I don't bother to write 2,000 parentheses 1.05 minus 1 because I know that's just 5% of 2,000. But the difference between year 3 and year 4 is only 1, so I can do this. But the difference between year 1 and year 3 is 2 years, and the only way to figure that out is to take the accumulated value, which is 2,000 times 1.05 squared, and minus the original 2,000 from it. That's the difference between 1 and 2 years. Okay, any other question? Next page. Comparison of amortization and sinking fund methods. Sinking fund. Assume a loan of L with interest rate I with the sinking fund method. So assume that we are taking a loan of L with the rate of I, and we are using the sinking fund method. Pay it back with sinking fund with rate J. Make N payments into the sinking fund which accumulate to L at the end of the life of the loan. Note, usually J is less than I. However, the advantage is that the borrower is in charge of the sinking fund account and has availability of funds throughout the life of the loan. So we know that IL plus L over S angle NJ is the total. IL is an interest payment per year. And this is sinking fund deposit per year. It's level sinking fund deposit per year. So this is just a repeat of what we said on the previous page, right? L is equal to Q S angle NJ, and therefore Q is equal to L over S angle NJ. So we know how this stuff works with the sinking fund. You're going to pay mom back IL, and you're going to put this level deposit into a sinking fund. What about amortization? Don't we know that L is equal to sum Q times A angle NI, where L is the present value of the payments of Q happening N times at interest rate I. So we're going to call this I prime, because I have a different I in the sinking fund method, where Q includes principal plus interest. Set these two payments equal, because they're both satisfying a loan of L. So I have every right to say that this payment Q, L over A angle NI prime, that's the payment from amortization, is equal to IL plus L over S angle NJ. So set both payments equal. Divide by L. So you get 1 over A angle NI prime is equal to I plus 1 over S angle NJ. I divided everything by L. Does this make sense to you? What's your question? Anything? Let's do the next one. John borrows $10,000 for 10 years at annual effective interest rate 10%. He can repay the loan using amortization with end-of-year total payments of 1627.45. Let's draw a timeline. Amortization at I equals 0.10, 0, 10, and each payment is 1627.45. Instead, he uses the sinking fund method with a sinking fund account with annual effective interest rate 14%. So J equals 14%. That's J. The deposits to the sinking fund account are equal to 1627.45 minus the interest due on the loan and are made at the end of each year. So I, for my sinking fund method, is equal to 10%. So they gave me I and J. Determine the balance in the sinking fund immediately after repayment of the loan. So let me draw my sinking fund method. Not only will I be putting IL, but I will also be putting money into a sinking fund. So because they're telling me that instead of putting 1627.45 into amortization, I can put 0.10 times 10,000, which is just equal to 1,000. I can put 1,000 into IL account, meaning paying back the interest, and the rest has to go into the sinking fund account. So the total amortization payment was 1627.45 after I finished paying IL. Only 627.45 will go into the sinking fund every year for 10 years. And they want to know what is the sinking fund balance after repayment of the loan. So I want to make you understand that these sinking fund problems, each one of them is different. They come with variations. So sometimes you're trying to accumulate the loan balance in your sinking fund, and sometimes that's not the case. Like in this problem, they're telling you, well, the fixed payment for amortization is 1627.45. You are going to be paying IL into the interest account. You're paying interest of IL, and you will have 627.45 left. In this case, the 627.45 is not going to accumulate to the loan balance. Are you understanding me? So in some problems, the idea is for the sinking fund payments to accumulate to L at the end. Here, that's not the case. Here it's saying, yes, I'm using a sinking fund, but into the sinking fund will go the difference between the amortization payment and the IL payment. So here you're paying 627.45 into the sinking fund, and this accumulation may be more or less than what you need to pay off the loan. So they're asking you, see how much this thing accumulates to, and if you have any money left, that's your money left to keep, because after you pay off the $10,000 loan, you may have some money left in that account or not. So go figure out what it is. That's what they're telling you. So accumulated value at time 10 in the sinking fund, or I should say of the sinking fund, is equal to 627.45 S angle 10 at 0.14. And our job is to figure out how much this is. So 627.45 times 1 plus 0.14 to the n, which is 10, minus 1 over I, 0.14. So when I clean this up, I get 12,133.19. That's the accumulated value into the of the sinking fund at time 10, right here. And so since I owe $10,000, 12,133.19 minus 10,000 would be 2,133.19. And that is the answer to this problem. Get it? Melissa, question? You don't have to do anything to that. They're trying to say that the payment here is equal to the total payment here. Yeah. That's all. Only in this problem. Okay. So,
So let's just say the loan balance was like 20,000. So then would you report a negative balance at the end of 10 years?
If the loan balance was 20, if the loan was 20,000, this would be double. But wait, let me explain. This would be double. This would not be 1627.45 because this amount would have been gotten by saying 20,000 equals QA angle N, and it wouldn't be 1627, it would be double, which means after you do IL, this would be double of 1,000, which would be 2,000, and then the rest would go into the sinking fund. Okay. So everything in the sinking, probably the accumulated value sinking fund would still be 2 times what it is now, because everything was just doubled. Okay. Does that answer your question? I cannot leave this as 627.45 and expect it to come out anything different than this. It would be double of it going in there. Okay. Questions? Okay. Next one. So before I move on, I should say something about the comparison of these two methods, right? So use the sinking fund method if IL plus L over S angle NJ is less than L over A angle NI prime, and use amortization otherwise. So in the previous problem, which method do you think you might want to use? In the previous problem, that's in the John problem, which method is preferable? Amortization or sinking fund? What do you think? Do you understand my question? In the previous question that we just did right here, which method is preferable? Simply paying back principal plus interest in every payment, or paying back IL and having 627.45 left to accumulate in the sinking fund? Which is preferable? Pardon? Sinking fund? Why? Therefore, is that your money to keep? Yeah. So the answer is sinking fund is preferable, because after you pay back the $10,000, you still have, how much was it? 2133 left over to keep. Get it? Yeah.
So you wouldn't be able to answer this question without fully doing out a problem first, or would you be able to figure it out
You can just look at this.
and solve that?
Yeah. You'd have to solve this in order to see. Yeah. Or you can skip the L's, but you could certainly solve this one, right? I plus 1 over S angle NJ. Is I plus 1 over S angle NJ less than 1 over A angle NI prime? If so, use sinking fund method. Okay, let's move on. Loans with other repayment patterns. Okay, so here's a formula that should go on your cheat sheet, will come in really handy. You know, some of the older problems that we were doing were asking you for OLB 83, and then the next part says find the interest in the 84th payment. So you would have to do I times OLB 83 to find capital I 84. Let's say the question then said, find the interest in the 85th payment. So now you're going to need little I times OLB 84. Given OLB 83, it is very easy to find OLB 84 using a formula such as this. So I would just do, by the way, B and OLB are the same, right? It's just saying balance. So this is saying B84 equals B83 times 1 plus I minus R, the whole payment R, 84. So you would no longer have to go back. I wish I could give you a proper example. Hang on for 1 second and I will explain what I mean. Take, for example, this question. So in this question, you have a fixed payment of $980. Oops, let me just do this properly. In this question, you have a fixed payment of $988.45 going on from time 0 to time 15. And they're telling you that for the first 5 years, the interest rate is some particular interest rate. And then from then on, you have a different interest rate. And the first question says, calculate the loan balance immediately after the 84th payment, right? So you go to this question, and you're trying to find OLB 84, which you have to do the long way because you don't have OLB 85 or 83 given to you. So I could go use that formula that I just mentioned. So in order to do this, I would be standing at 84, looking at the payments that are left, and saying, find me the present value of the payments that are left. The problem here is that in this question, they're telling you that the last payment is different than all the other payments. So it's a balloon payment. So I can't even do prospective method because the last payment is unknown. So I would have to go backwards to retrospective method, and I would have to take L and grow it all these years at 2 different interest rates because the interest rate changes here, minus the accumulated value of all the payments that have already been made. And again, I would be accumulating at 2 different interest rates. So that's what I did here, okay? Assuming that I was able to do that, and I got OLB 84 is equal to some amount. Now I go to the next question, and it says, calculate the amount of interest in the 84th payment. So for this one, I need capital I-84, which is the interest in the 84th payment, is equal to lowercase I times OLB 83. But I don't know OLB 83. I would have to do this whole thing, something similar to this, for OLB 83. But not really if you know this other formula, right? Which puts OLB 83 in terms of OLB 84. So in an example like this is where that formula would come in handy. It says OLB at time t is equal to OLB at time t minus 1 times 1 plus I minus R of t, where R of t is the total payment at time t. Are you following me? So I'll go back. You refer to this later to see how it comes in handy. And let's talk about this formula. Okay, so we know that balance at time t is equal to balance at t minus 1 minus P of t from the amortization schedule. So balance at t minus 1 minus P of t can be replaced by R of t minus I of t, because we know that the total payment is made up of the principal payment plus the interest payment. Next, you're going to replace this I of t by lowercase I times balance at t minus 1. And then clean it up. Balance at t minus 1 plus balance at t minus 1 times I minus R of t, which is equal to balance at t minus 1, parentheses 1 plus I minus R of t. And that's what this is saying. So I'm just manipulating by stuff I already know, right? One thing I used is that the principal part of the payment is equal to the total payment minus the interest part of the payment. And another formula that I used is that the interest at time t is equal to the interest rate times the balance at time t minus 1. And when I make these substitutions, I am able to get a formula for OLBT in terms of OLBT minus 1. Follow or no? Okay, I have to stop here because it's going to stop recording here. So for every problem now where they ask you for OLBT, do not do the OLBT from scratch if you already have OLBT minus 1 already done with a proper method. Just substitute. No matter if the payments are growing or not, you can always use this method.